This is Scott from KIG. It's December 14th, 2018. And today we're going to do a couple, 2 or 3 runoff videos for this 2014 7.5 ton Cold Shot, otherwise known as Zarsky, air-cooled process chiller. We can call it a glycol chiller because we have this set up, tested, and ready for a brewery application. So it's going to chill down to 25 Fahrenheit glycol. This is a 208/230 3-phase machine. Again, 2014, using our 410A refrigerant. And I have the covers off. We have all the covers over there, as you can see, and I have the lid of the tank off also. Just to go over a couple things, some key components and so forth. One of the main things we do on a refurbished or used chiller for a glycol brewery application is we ensure that the piping is correct for the glycol loop. In this case, we had to modify that. So what that means is we have an additional, well, we put in a new return line, which is this line here, coming back to the tank, and that's what you can see set up right here. That's our new return line, and we actually had to cap the old return line. So what does all that mean? So in this unit here, it has an upsize, which is nice, 3 horsepower glycol pump. This is the suction side of the pump here. So we draw from the tank, then we come up and we split off into two zones on the output, if you will. One here comes out to our process, so where it says out here is still accurate on the chiller. Okay, the other one comes directly back to the chiller through a globe valve here, makes a turn right here, and comes directly back into the process tank, or the glycol tank, where it goes directly into the heat exchanger, which is submerged in the tank. So what that does is that ensures a heat exchanger, a brazed plate heat exchanger, consumes a certain amount of pressure. So this ensures that we always have that component of the equation satisfied, and we know we're getting enough flow to go back to the exchanger because of this flow switch. The other portion of the flow goes out to the processor tanks. So in this situation here, you're not going to have to have your own bypass valve where your supply meets your return on your process tanks. So we have a globe valve here which adjusts the amount of flow going back to the heat exchanger in the chiller. If it's not enough, that flow switch will trip it out. Okay. At the same time, we need to make sure that there's enough back pressure. Here we just have a loop, but at the same time we have to make sure there's enough back pressure in your glycol loop so that the pump does not overamp. A pump likes to see back pressure and so forth. Some of the key components we have, other key components we have, is the 7.5 horsepower compressor. We have a switch here for low ambient controls that works in conjunction with a fan speed control. So if it's below 0 degrees, this switch activates the P66 fan speed control. If it's above 0 degrees outside, then it's just going to go off fan switching to satisfy the low ambient conditions. This has a phase monitor, so upon initial startup, if you put the wrong phase, it won't let you start it, and you just press the default reset button after you change any 2 of the main incoming power leads on the main contactor here. Here we have just a time delay. That's to prevent nuisance low pressure startups in cold weather. Right here, this is important. That jumper stays here unless you want to tie in to terminal 1 and 2 for a remote control contact. And this is your pump contactor, and you'll see I actually have a amp meter on there because I'm going to talk a little bit about full load amp specifically for the pump. Okay, so I'm going to come back here in a second, and we're going to turn for video number 2 and then turn it on and start chilling and talk some more.